Today we are going to discuss the reactions of phenylamine. Actually, we started the reactions of phenylamine in the previous class. And one thing which we noticed that as we usually divide these reactions into two parts, the reactions due to side chains and reactions on the benzene ring. So we divide them into the two parts. The reactions due to benzene ring of the phenylamine, in the last class we said that they will be exactly the same as we had the reactions of phenol on the benzene ring. Why? Because the phenol benzene ring is the phenol's benzene ring has the same mesomeric effect where the lone pair of electron goes down, delocalized over the ring. Just like that, that phenylamine's nitrogen has a lone pair of electron, which is delocalized over the ring, which increases the electron density of delocalized pi electron cloud, similar to phenol. Hence, the benzene ring of the phenylamine is also very active. Okay? So, therefore, you see the reactions taking place on the benzene ring are the same. Nitration with the same reagent condition 246, chlorination, bromination, and alkylation, acylation, just like phenol. Okay. Now today we are moving on. That was the thing which we left yesterday. Now today we are going to move on with the reactions of phenylamine on the side chain, right? So reactions of phenylamine on the side chain, please. Give a heading. Reactions of phenylamine. Yeah. On the side chain, yes. This is the topic. So if you look at the side chain, bacho, the side chain of phenylamine is this NH2, right? If we see this compound, we'll discuss in detail later, but at this moment, I'm going to give you the need to know basic information. This is what? An inorganic compound, ammonia. We all know ammonia is a base. Why? Because it uses its lone pair of electron and accepts what? Proton. Therefore, it's a base. The same lone pair of electron is still present because what we did, we just replaced one of the hydrogen with this ring. That's it. So it becomes phenylamine. So phenylamine still has that lone pair of electron which can accept. Right? So phenylamine or any other amine are always bases because they can accept protons, right? Because of their lone pair of electron on the nitrogen atom. So please write down all amines, including phenylamine, are bases. Why? Because they are proton accepting. Yes. They accept proton or H positive ion. Right? So the first reaction on the side chain is the basicity. Here is the phenylamine plus H positive ion gives us what? Yes. So it accepts proton and turns into what? NH3 positive. Is it a reaction or you are just giving? Yeah, it's a reaction. So phenylamine, you see, accepted a proton. Similarly, look, if this is phenylamine, reacts with HCl and forms what? NCl, sorry. NH3 positive, Cl negative. So I just wrote the complete reaction in which a base, phenylamine, reacts with an acid. That's how the basicity of phenylamine is. Number two, the second reaction. Reaction with NaNO2 and HCl. How phenylamine reacts with NaNO2 and HCl. I'm just straightforwardly writing the reaction. Look, this is phenylamine. It reacts with NaNO2 and HCl. Yeah. That forms, look at this, N2Cl plus NaCl plus H2O. This N2Cl is an organic salt, positive negative charge, known as benzene diazonium chloride, which is BDC. So NaNO2 plus HCl, they both are reagents or one of them is reactant? No, this is what I'm going to explain. If you look at this reaction closely, kids, this reaction seems quite weird because we have seen very few times a reaction has two reagents. I'm not saying anything catalyst here. And we have seen very, very rarely the reaction has this much temperature. Because reaction needs a more temperature so they can react fast. And especially the organic reactants, they have a strong covalent bonds. They always need catalysts. They always need good reagents. They always need high temperature. So that's why I'm going to explain this reaction in the detail. It's not a mechanism, it's just an explanation, okay? Keep in mind, it's just an explanation. Now look at this. What actually happens? This reaction of the phenylamine is not with NaNO2 or HCl. This is the reaction of phenylamine, which is a base, with an acid, HNO2, known as nitrous acid. So why we use the other reagents? Actually, nitrous acid is highly unstable. So we can't have nitrous acid before the reaction. So what we do, in the reaction mixture, we mix NaNO2 with HCl at a very low temperature, less than 10 degree, preferably 0 to 5. And we allow the NaNO2 or HCl to react what? HNO2 plus NaCl. This HNO2 is quite unstable at this moment, under this temperature. So immediately it reacts because phenylamine is already there. So it is just prepared in the same reaction mixture, right? So we just mix them like this. Here. Phenylamine is already there. And you added what? Yes. And HCl. They reacted to produce what? Yes. Yes. So HNO2 reacts with what? Phenylamine. So it's basically an acid-base reaction. It's an acid-base reaction. This is a base. This is an acid. But being acid unstable, we have to prepare in the reaction. That was the point, actually. Okay? So this turned. Now, what happens next? Now, let me explain this part as well. When they combine, look at this. The NH2 part is like this now. And I'm not going into the much detail like this. Right? This is called benzene diazonium ion. Benzene diazonium ion. Okay. And then in the next step, because benzene diazonium ion, where it is formed, there is a lot of Cl negative ion already there because of NaCl. They turn into what? They turn into this. A salt known as benzene diazonium chloride. Okay? BDC. So here it is the complete detail. It's not a mechanism. It's just for the sake of your understanding that how BDC is formed from phenylamine. Okay? Okay? Right. Okay. Now, next reaction. So this is phenylamine turns into BDC by the reaction of NaNO2 HCl 0 to 5 degree, and BDC is what? You see, it's a benzene diazonium chloride. It's an organic salt. Okay. Now, next reaction. Number 3. This is known as. Yeah. Yeah, they can ask you. They can ask you. Coupling reaction. Coupling reaction, the next. Okay. Now, this reaction again, very important. Listen, everyone. Coupling reaction. Look at this. In this reaction, first listen to me, then I'll dictate. This is phenylamine. It reacts with BDC, the compound it is just formed, BDC. In the presence of NaOH aqueous catalyst. Yes.
सर एक बार ऊपर करें ना, मैं डिस्कनेक्ट हो रहा हूँ बार बार.
Yes. Here it is. Now, can you take Muhammad's screenshot, please?
हो गया सर, थैंक यू.
Okay, next. Next is the coupling reaction. This is phenylamine. This is BDC. Okay. Now look at this. Please pay attention. BDC we know is a like Na positive Cl negative. It's a salt now. Now please pay attention. So it's iska jo positive part hai, this one which I'm highlighting. It's a kind of electrophile. And we know that in phenylamine, if an electrophile comes in, it's going to react, not the phenyl NH2 part. It's going to react with what part? Benzene. And what the electrophile does? Yes, substitutes one of the hydrogen on the benzene rings. Right? The question is where? You know where they prefer? 2, 4, or 6, right? So this is what happens. Okay, when you mix phenylamine with BDC, the BDC's benzene diazonium ion, which is an electrophile, that goes and takes the place of hydrogen, electrophilic substitution reaction kind of, at either carbon number 4 or carbon number 2, preferably 4. So what happens now? In other words, I'm just trying to say that this hydrogen, look at this, will combine with this HCl to form what? HCl, and the other part, the electrophile part, is going to take the place of this hydrogen, the substitute this hydrogen. So what is the product form? Now this is the interesting. Product has the upper ring NH2, right? And down there is what? N2 and then benzene ring here. So this is the compound that is formed. Now listen, this N2, right? This is the compound that is formed. This N2 is known as azo. Now the compound that is formed has a new functional group which you can identify here. And this new functional group is what? N2. This is known as azo functional group. What do you call it? Azo. And this compound, is a colored compound. So we usually call it dye. So they are commonly known as azo dyes. Just for the sake of information, methyl orange is one of the azo dyes. Okay? Or other the compounds which are used to color the clothes, the textile industry, they are mostly azo dyes. Right? So this is the compound. So what I'm trying to say, when phenylamine reacts with the BDC in the presence of NaOH aqueous, they form another compound with a new functional group, azo dye, along with HCl. But this reaction is actually a kind of electrophilic substitution reaction in which the BDC's electrophile, the BDC's benzene diazoniamine, comes and takes the place of hydrogen on the benzene ring of phenylamine. So now here that one thing clicks in my mind. We have just learned previously that phenols reaction on the benzene ring are always similar to the reaction of phenylamine on the. So it means this the same reaction will also be happening with what? Phenol. Because phenol has also the same nature. So let's see. Here is the phenol.
So with BTC?
Yes. So phenol also reacts with BDC. Here. NaOH aqueous to form what? Right. So what is this? Or either carbon number 2 or carbon number 4. This thing which I show you, the here, you're not supposed to show this one. I'm just explaining it. That's why I'm showing this. This this Cl mills combine to form HCl. You're not supposed to show this, right? So the benzene diazoniamine is going to come and take the place of carbon number 4. They can do the same thing on carbon number 2. Okay. Now, in order to explain this, here is a double bond between two nitrogen. And here it is. And this is the azo group. Okay. Plus HCl. And we added sodium hydroxide to neutralize the HCl. Right. So again, this is the. We can explain it, but some other time because how the bonds rearrange. At this moment, you just have to keep in mind how the third bond of iron breaks. So it is a kind of native covalent bond that has been broken down, and now it turned into a double bond. Okay. This is again azodie that is formed. This is phenol and phenyl, azophenol, and the one that is top and phenyl, azophenylamine. These are the dyes which are formed, right? So now I'm going to give you a couple of the reactions. Look, this is another compound. Look, what the examiner do? Look, this is called naphthol. What is this? Yeah, this is a type of phenol. When naphthol reacts with BDC, I'll follow you. Can you please do it? When naphthol reacts with BDC, can you tell me the product that is formed? Draw the structure of the product, please.
So what is basically a BTC?
Benzene diazonium chloride. This is a salt that is formed, right? I'll tell you in the end how this salt is formed. We just did it. We made it from phenylamine. No, you have to draw the structure, then explain. First draw the structure, then I'll ask the explanation, okay? One more.
So it will again react with NaOH. The catalyst will be NaOH.
Yes. NaOH is not a catalyst. NaOH is a kind of solvent which is used to neutralize the HCl that is formed in every type. Okay. So NaOH always used. Please draw the structure of azo dyes formed in these two reactions. When naphthol reacts with BDC,
In the second one, it will it's one of CH.
sorry,
So it will in the second one it will calculate this the H from the benzene ring, the side chain down.
on the benzene ring. Let me explain. The first one, either carbon number 2 or carbon number 4, the hydrogen is replaced. Now I'm not going to draw that thing. OH. And now look at the carbon number 4. Here it is N, double bond N, and then. So on purpose, I'm just showing it this way. So you can understand it's not like showing it down. Plus HCl.
Secondly, just explain the structure of naphthalene. Like
Yeah, naphthol is just an phenol with an extra ring. So there's no explanation in this case.
so there are double bond in between the carbon bond on the.
No, this is a delocalized pi electron cloud in both rings. The resonating ones. Okay, next, what about this? In this case, the fourth carbon is already what? Taken, blocked, substituted. So which is, we are left with what? 2 on the both side. Any side you can choose. Here. No, no. The hydrogen that is directly attached with the carbon that can only be substituted. So that hydrogen has already been substituted. Here it was hydrogen. You can understand like this. If we had a phenol, first we reacted it with methyl chloride, for example, CH3Cl, AlCl3 catalyst. And this hydrogen has already been substituted with HCl. And this CH3 takes the place. And now this CH3 has hydrogen has already substituted and methyl has come. There is no hydrogen there. So then carbon number 4 hydrogen has already been substituted with methyl group. So next is carbon number 2 hydrogen, which can be used to replace this. Okay? Here. Plus HCl. Okay? These are all the azo dyes which are formed. They are the containing another new functional group known as azo functional group. Okay? They are the colored compounds. That's why we call them dyes. Now, what the examiners do to make things tricky, they ask you the question in a reverse order. Instead of asking you I am asking you to draw the structure. So they ask you this in the reverse order. They give you the structure of an azo dye, and they expect you to reach to the backwards, reach to the benzene point. For example, now I'm giving you a kind of question, the past paper question. Look at this. Okay, now this is the question. First, you understand, okay? They say that we have this compound, please look at this.
सर ये लिखना है या आप एग्जांपल से बता रहे हैं?
Yeah, you have to write. You have to write. Now, this is the question. You have to write, please, everyone. They ask you that this compound is formed by the multiple steps, right? You have to identify the compounds, let's say A, B, C, D, and E. Now look at this. First, I have to look at this compound closely. As soon as I see the azo group, I understand that this is an azo dye. Azo dye has always two parts. One part comes from either phenol or phenylamine, the other part comes from BDC. So now I have to understand which part comes from BDC and which part comes from phenol. Although I can see there is no OH or NH2, but this ONA, I can understand that this is the phenol's part actually. Because when phenol reacts with Na or NaOH, so it turns into this. So oxygen is there still. So its property is still there. So it's a kind of phenol. Okay? And then there is CH3. So I now understand that this part of the molecule can be taken as phenol. And this part of the molecule, BDC. Okay? This is the phenol and this is what? BDC. Now I know the E part of the compound. So let me write E first of all. E is my BDC. And I can see the BDC is like this here. And then one extra thing which I can see is SO3H. There's another extra thing attached with this. So now I can identify E. And I can also identify, for example, this. Now a while ago I told you, okay, when you mix these two together, what will be the product? Tell me. If I mix these two together,
Cl will attach with the X.
yes. Which H?
So the Cl will be broken down, will be taken away, and
Look, this H and this Cl will combine to form what? HCl. And this whole thing comes and attaches here. That is the product. So I asked the question in reverse order. I showed you the product and I asked you the. Now you understand? The reactants. Now then he says where this reactant comes from. Then you can see that this part we already agreed that this is actually what? Yes, this is an OH. So C I know is phenol. I just reacted it with either Na or NaOH. Here I reacted with Na or NaOH. That's why it becomes D. This is D my. Okay? And this is what? E. C. Again, he is asking, what is your B?
so the CH3.
Yes. The phenol is substituted with CH3. And we know that B is the phenol without CH3. Okay? And then this CH3Cl in the presence of AlCl3 catalyst. That made this one. Okay, that is your what? B.
So B will, what will be CH3 or the phenol?
No, phenol. We are just looking at organic compounds. So, okay, let me write them if it's confusing. B is this, phenol. C is this. Yes, phenol with, it's a phenol with CH3 underneath. Okay. And then what is D? D is the ONA. Okay. And then what is
The benzene ring? Yes, the benzene ring.
yes. What about A? Now come to the A. No, benzene ring cannot make phenol. Now I have to tell you this. If you go back to the notes, I have to tell you this. I believe I told you this. The BDC, this BDC, you know, when added with warm water, it turns into phenol. This is the one of the method of preparation of phenol. I hope I told you this reaction. Or you can just write it here. Okay, BDC, when added with warm water,
Yes, sir.
phenol, yes. There is no mechanism or there is no detail of this reaction. You just have to memorize it. Okay, when BDC is added with warm water, it turns into what? Phenol. So what is on the top actually again? Yes, this is the BDC. I hope you got it. So we took BDC. Yes. We took what? This is BDC. So I'll explain it again like this way. We took BDC and added what? Warm water. It become what? Phenol. Then we took phenol and reacted it with what? CH3Cl in the presence of AlCl3. It turned into 4-methyl phenol. Then we took Na or NaOH and mixed it to make ONA. Then we again took another molecule of BDC that is having SO3H on the carbon number 3. And then we mix them together using NaOH aqueous as a solvent. And it turned into what?
HCl and this compound.
Yes. So I'm gonna show you the whole molecule. जो लोग जूम पे उनको भी समझ आ गया ये क्या हुआ है ये सारा
Second, yeah, just yes, sir. Sir, can you share this book on the group?
yeah the recordings are already in the group you must visit it once
Where on the YouTube, what I'm saying about the book.
book me notes yeah I will
Sir, D to E can bind.
no D to E nahi. D and E combine together D can't turn into E D combines with E to form let's say F label it as F the azo dye is labeled as F. Is it clear?
Yes.
So this is the how the reactions of phenylamine. That is all about the reactions of phenylamine, right? So we're gonna discuss the questions here now because we have done the benzene and its derivatives. Benzene, methylbenzene, phenol, phenylamine. Okay. Now we're gonna do some questions here related to yes benzene and its derivatives. Okay. For example, let me write a question here. Okay, let me give you a question. Again, the same question. Before going to the past paper question, I'm just left with 5 minutes, so I'm going to give you a question again. Okay, here is the question. Bacho. Quickly, you have to do. We just have 5 minutes. Here it is. So again, the same type of question. You have to tell me these compounds, this one and this one. Okay? Then this one. This, and then finally this. You have to tell me all these compounds. Let's start from here. Do you identify what functional group is this? And which type of compound is this?
The right one is methyl. The right one.
Azodie always consists of two parts, BDC and phenol or phenylamine. So you have to first break them into two parts. Yes, this part is BDC. And what about this part? Phenol or phenylamine? So BDC, I'm gonna first write here. NH2 is phenylamine and OH is phenol. So I'm gonna write BDC here. Okay. And then CH3 here.
But with the
So this is the compound here.
BDC, you have attached CH3. So how it can
That's
be
fine. Could be.
Could be.
Yeah. What about this? This is phenylamine again having what? CH3 at carbon number 2. Now what is this formed actually? Alkylation. So it should be what? Phenylamine without CH3. And phenylamine is formed from what? You remember? It is formed from nitrobenzene. And you know nitrobenzene is formed from what? It formed from benzene. So here you go. They ask you then the reagent and conditions for each step. What about this? The first step, second step, third step.
CH3 and with the ASA.
Here is another compound. You have to identify this one as well. This one.
CH3.
This one. No. The one which makes the BDC.
The CH3 Cl with.
No, BDC is formed from phenol. It should be a phenol with CH3 on the carbon number. Because by adding what? Warm water. Now, what are the reagent conditions for the first step?
BDC में warm water डालें तो phenol बनता है.
Yeah.
लेकिन ये reverse हो गया.
No, this one, sorry. What is this compound actually? Okay. Now, what about this? Sorry? Concentrated and
H2 is
And-
50 to 60 degree.
and what about the next tin with concentrated HCl and heat reduction now? And then what about this? CH3Cl AlCl3. And then what about this? NaOH aqueous. So that's all. We'll continue with this. And tomorrow we are going to discuss the questions which we have done up till now. Benzene, methyl benzene, phenol and phenylamine. Thank you.